Hello guys, welcome back to the second set of videos in our triangles unit. Today we're going to talk about two really important theorems that you're going to probably forget after a while that they're theorems because you're going to do it so much, but they are theorems. Remember, theorems are statements that needed to be proved. So one time long ago someone proved these and now we can accept them as true. Alright? The first one I have alluded to in class many times before, and that's the triangle sum theorem. We can just call that the TST if you want. And it says the sum of the measures of the angles of a triangle is 180 degrees. All right, so all of the interior angles, angle A plus angle B plus angle C, they would have to add up to 180 degrees, always. Okay, the second theorem, this one might take a little bit more practice to get used to, but it's called the Exterior Angle Theorem, or EAT. We like to abbreviate a lot in geometry. You're going to see that actually here real soon with some of these other triangle theorems that we're going to be talking about. And here's the definition of an exterior angle. Okay, an exterior angle is formed by extending any one side of the triangle. So you see this base here, it was extended a little bit past, that vertex right here. And what it does is it creates this angle right here, which is angle 1. Okay, angle 1 is the exterior angle. And this theorem says basically that the measure of angle 1 will equal the sum of the two non-adjacent interior angles. Now, this word non-adjacent, you know what adjacent means, okay? Two angles that share a vertex and a common side. So like 1 and, let me just give this angle in here name 4, right? Like angle 1 and 4, those would be adjacent. So angles 1 and then 2 and 3, which are these guys over here, they're not touching 1. Those are the non-adjacent angles, okay? And we could just do a little proof here, right? Because we're left with this statement, the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Well, what would we know about angles 2, 3, and 4? Well, what if we added those up, okay? If we added the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, we know that that gets us 180, right? That's by the theorem we just talked about up top. And we also know, if you look at 1 and 4, what relationship are they in? They're in a linear pair relationship, right? Those are in a linear pair relationship, and we know that linear pairs are supplementary and adjacent angles. Now, what do we notice here? We have two expressions that both equal 180 degrees. So what could I do? I could substitute one of these expressions for another, okay? So let me just get real fancy here. Let me copy this. Okay, so we know, it's okay, I'll erase this. We know that this is going to equal this other expression. Okay, now what looks the same on both sides of the expression? The measure of angle 4, right? So I could just subtract it on both sides and end up with the measure of angle 1 on this side is equal to the measure of angle 2 plus the measure of angle 3, right? So just a really quick informal proof to prove to you why we can say this and how we're going to go about that, right? All right, so let's move on to some of these problems. I've circled the ones that I really want to hit. And just so you know, the ones that I don't hit in the videos, there is that PDF available for you on Edsby to look at any time, right? Okay, so number 2, what theorem is this? Triangle sum or exterior angle theorem? Well, if I want the measure of angle 1, right, and I know the two non-adjacent angles, I know that the measure of angle 1 will equal the sum of those two angles. So you just get out your handy dandy calculator, yes. Okay, 76 plus 52 degrees, that is 128 degrees. There we go. Quite simple. All right. Now what about number 3? This is another exterior angles theorem problem, but in this case, it's one of the non-adjacent angles that we don't know. All right. So we know the exterior. We know one of the non-adjacents. And we know if we add the two non-adjacents, which are these two, right? Let's group them together. We know if we add those together, the measure of angle 1 plus 79 degrees, we're going to get that exterior angle, 104 degrees, right? So we just subtract on both sides 79 degrees from 104, and you get 25 degrees. Okay. So obviously we wish all problems were this simple, but we're going to get into some messy ones, and we're going to get into some problems that relate back to topics that we've already talked about. All right. Number 4. So this one, if you could count the triangles in here, you would probably say 2, okay, but realize that there are 2 small ones inside the much bigger one, right? So there's technically 3, okay? Now we want to know the measure of angle 1 and the measure of angle 2 and the measure of angle 3, and we can do this in a couple of different ways. Let me draw your attention first to the measure of angle 1. That belongs to this triangle, right? If we zoom in just to focus here, it's really not that hard to see that the measure of angle 1 is the only unknown angle in this really skinny triangle. We know the two base angles, 66 degrees and 84 degrees. And if we add all the angles up in a triangle, we know we're going to get 180 degrees. Okay? So some really quick math. Oops, don't want to do that yet. I want to add the 66 and the 84 together to get 150. Set that equal to 180 degrees. Subtract 150 on both sides, and we get 30 degrees for the measure of angle 1. All right, so he's good to go. Now, the next one that is going to be easiest to solve is this one down here, the measure of angle 3. And the reason why I say that's the easiest to solve is because, look, these two angles, the 84 degrees and this angle right here, the measure of angle 3, are a linear pair. So what do they add up to? They add up to 180 degrees. It seems like the magic number, okay? So subtract 84 on both sides. We get the measure of angle 3 is equal to 180 minus 84, which is 96 degrees. That makes sense, right? It looks obtuse. All right, so this is 96. This right here is 30. So we're only left with the measure of angle 2. There's a couple ways you can go about doing this, but I'm going to go with the most simplistic method, okay? And for those of us who are catching on a little faster than others, then you can maybe figure out the other ways and then let me know in class. But I'm just going to show you that this one is actually a lot simpler than you think. Let's just look at this big triangle right here. The one with the 2, the 3, and the 43 degrees. We know that if we add all those angles up, we would get 180. So we know the measure of angle 2 plus 96 degrees plus 43 degrees is equal to 180 degrees. Okay? So 96 plus 43. Oops. 96 plus 43. It's 139 degrees. Equal that to 180. Measure of angle 2 is going to equal 180 minus 139, and we're going to get 41 degrees. So there we go. All right. Number 6. What do we notice right off the back of number 6? We got two triangles, okay? And these two triangles, they share a vertex. They're kissing triangles. So what do you know already right off the back? Kissing triangles create vertical angles. So what two angles are vertical? The 61 degrees and this angle 2, which is unknown, quote unquote. Well, we know that vertical angles are always congruent to each other by the vertical angles theorem, right? So I know right off the back, the measure of angle 2 is 61 degrees. That is super easy. All right, so now you can either do either one, right? Measure of angle 1, let's just knock that out. Now I know you're going to start doing this a lot in your head, okay? You're going to start being like, okay, well, I know how to set this up, and it takes a lot of time to set it up, and I'm tired of writing. I'd rather just do the math, and why do I have to show my work? But it's really important, okay? Because you know what's coming. You know that eventually we're going to have to start doing proofs with this, right? So if you just get in the habit now of writing out every single step, then the proofs are going to be a lot easier for you when they come. All right. Through my talking, I've figured out that the measure of angle 1 is 51 degrees. So I'm good to go there. All right. Finally, we have this right triangle down here. So we know that this little box man, he equals 90 degrees. And I know the measure of angle 2 is equal to 61 degrees. So set up my equation. $90 plus 61, 151, so 180 degrees. The measure of angle 3 will equal 29 degrees. All right, easy as that. All right, 97, or sorry, not 97, it's just 7. I don't know where 97 came from. All right, so I've already previewed this problem for you, and I read that the segment BC bisects angle ACD, right? Well, you know, use a little highlighter. Where's ACD at? It's right here. We know that BC is the bisector. Bisector literally means to cut in half. Well, angle C is a 90-degree angle. So that means that these two angles right here have to be 45 degrees. Well, that's just lovely. I didn't even have to do any math. I just had to know the definition of a bisector and a right angle. Okay? So we know that these are both going to be 45 degrees. Praise God. All right. Let's get rid of some of these highlights. All right. So now angle 1 becomes very simple to solve. The measure of angle 1 plus the 45 degrees down there plus the 48 degrees right there, it equals 180 degrees. (180 minus 93), that's 87 degrees. All right. And therefore, we have, let me just get a different color. I'm tired of this one. We'll do that. Okay. We know the measure of angle 4 plus this 45 degrees plus the 83 degrees. That's going to equal 180. Add them up. 180 minus 128. That gives us 52 degrees. All right. So I'm going to stop the video here just because I know we're about to get into more advanced problems and you may want to take a break. You may want to, slow this down or maybe try some of these other left examples unknown like number 5, number 1. And then we're going to get into some of these good ones down here in the next video. Okay?